Okay, I want to introduce you to the scientific method here in Chapter 1, and this goes along with the lab as well that you have to do. Now, these are just the objectives that we're going to look at. Of course, we'll learn the steps in the scientific method and how you come up with a hypothesis and what a theory is. But let me ask you a question first. Can the common cold be cured? You know, we've all gotten a lot of advice from friends and family about how to treat a cold. Do you drink echinacea tea or meditate or get more rest, wear a warm hat, eat chicken soup? That might be advice you've gotten from friends and family. But how would a scientist determine how to answer this question? Which advice is the best advice? First of all, we need to define what science is. Science is a body of knowledge. Like you're taking biology. Biology is the study of what we know about living organisms. It's the discovery of something new and unknown. But it is not just recalling specific facts and memorizing what we already know. Now, I'm going to switch over to our note card notes. And this is where you would find the answer for the first objective, define science. If we go back, and you'll write it over here on this side of the page, if we go back to the PowerPoint, science is a body of knowledge, the discovery of something new and unknown. So that answers the first objective. Now, the scientific method has several steps. First, we make observations and we ask questions and we identify problems by using our senses. You smell something, you taste something, you see something, you hear something, and you make an observation. You come up with something that puzzles you, something you're looking for an answer to, or you want to know why it's like it is. Then you form a hypothesis. You propose ideas of what the reason is for what you've seen. We used to say it's a testable explanation. And to work in science, it does have to be testable. That leads us to experiment. This is where we design an experiment that tests our hypothesis. And we collect data as we perform this experiment. And then we draw conclusions. And we either discard that hypothesis or we might repeat it over and over to see if we get the same results, or we might modify it a little bit. So those are the steps of the scientific method. And if we go back to those note card notes one more time, list the steps of the scientific method. And you would list them over here: observation, hypothesis, experiment, conclusion. Define hypothesis and describe the characteristics of a scientific hypothesis. That's our next objective. So going back to the PowerPoint, a hypothesis is a proposed explanation for our observations. Our observations led us to questions. So we come up with explanations for what we've seen. And the best hypothesis is made using what's called inductive reasoning, where you combine a series of specific observations to discern a general principle. You observe it through your eyes. You have an imagination. You use that. You have some intuition. You know that chance plays a part in it. You try to be logical. You've got past experiences. There's other scientific research and results. You put all that together and you come up with a proposed explanation. So that would answer what a hypothesis is. Your mom's observation, it's cold outside. That's her observation. So her hypothesis that she comes up with based on her observations, her past experiences, logic, and intuition is dressing warmly will help you avoid a cold because becoming chilled makes you more susceptible to illness. That makes sense, right? So she's come up with a hypothesis. Let's ask a question. Colds are generated by disturbances in psychic energy is a testable statement. Can you test that? If so, answer true. If not, the answer is false. Well, it's false. Because how can we measure psychic energy? That borders on the mystical or supernatural stuff, and that's not something that we can see or measure or definitely. So it doesn't work in science to use anything supernatural. But the characteristics of a good hypothesis, it has to be testable and falsifiable. You got to be able to test it and evaluate it, and you might just possibly prove it false. And if you do prove it false, you're going to turn around and modify it and come up with another one. So define hypothesis is the testable explanation, and the characteristics of a scientific hypothesis, it's testable and it's falsifiable. So I'm not going to keep going back and forth to these note card notes, but do you see how you use the PowerPoint in the video lectures to answer these? Now going back to the PowerPoint, which statement is a scientific hypothesis? Read them over. Would you say A is a hypothesis? No, it's an opinion. What about B? You ever seen a garden fairy for real? So we can't test that, can we? How about C? Again, it's an opinion. But look at D. Increasing the amount of protein in a cow's diet increases milk yield. Can you test it? Yes. Could you possibly prove it false? Yes. So our answer would be D. That's a scientific hypothesis. Now, we use theory a lot every day. You know, people will say, I have a theory about the best way to get from here to Atlanta. Or my judgment says the best way to get from here to Atlanta is to take this road. That's just my idea. You may have a different idea. We haven't really tested it. But maybe I've gone several different ways and I found this to be the best one for me, but it's not really, I've not conducted a test because traffic would be an issue and so forth. But in science, a scientific theory is a powerful, broad explanation for related observations. It's based on hypotheses that have been supported by lots of different scientists and lots of different lines of research, independent research.